Cool. Thank you, Jojo. And I think we're gonna be playing like next slides and all of that for a while. But yes, first of all, thank you for the introduction and thank you for having me and the time to talk about zero knowledge, to also present some of the work that we have been doing as a PSE team. And yeah, I hope to have this presentation in a light mood, like not so serious, and hopefully we can have a good time also discussing at the end of the presentation. So feel free to, I don't know, like if there's a chat, add the questions there, or just at the end, save it. So thank you. What we're going to talk about today, it's going to be like 4 points in the agenda. The first one, yep, it's an introduction about PSE and its projects. So I'm going to talk about what is our team, what do we do, and what type of projects does it exist in our ecosystem that we have built and that are available. The second part is like, if you're a CKP developer, like where can you contribute to these projects or how can you get involved? I think that's also very relevant. And I think here's where we're going to spend the most time, like in these first 2 points. And then also from Key, I got a few questions that maybe we'll try to answer here, which is privacy versus transparency. Like, can both coexist or are they contradictory? Future vision of CKML, so zero knowledge machine learning from our PSE perspective. I'll have some caveats there as I'm not an expert, but I've gathered some interesting information. And yeah, like I will try to answer this in this 30, 45 minutes, and then like in the rest of the Q&A. But we can always have a conversation and continue afterwards. So first, let's define who is PSE. Who are we? So PSE stands for Privacy and Scaling Explorations. That's the full name of our team. And we are a team supported by the Ethereum Foundation, which it has its goal to enhance Ethereum through cryptographic research. So all that we do is public goods for the ecosystem to continue expanding the use cases, the capabilities, and the goals and the possibilities on Ethereum. Most of our work is around zero knowledge, but actually we have people doing other things like MPC, multi-party computation, other type of programmable cryptography that we're exploring is like full homomorphic encryption, and even later, like that's very far away still, but like time release cryptography and many other crazy things that we like to explore. So mainly still right now it's CKP. That's a picture of like part of our team on DevCon. But right now that's like less than half. I think right now we're over 60 or 80 people. So as you can imagine, it's hard to keep track of all the projects and things that the team is doing. And the team is distributed everywhere in the world. Like I'm from Costa Rica, but we have people, yeah, in Asia, tons, in many different countries, in Europe, in Latin America, North America, etc. So what do? We build public goods like circuits, gadgets, protocols, demo applications, proof of concepts, libraries, DSLs, like domain-specific languages, and other things. And we open source everything that we do. So our goal, as I was saying, is like keep expanding Ethereum. And the 2 areas of research that we have right now is privacy and scaling Ethereum, as our name suggests. We usually support also teams or the people with grants. So there are projects that we sometimes are interested to seeing existing on Ethereum, and we can like support teams building on top of that, whether that be like trustless on-ramp, off-ramps, or different ways to interact with Ethereum, or cool applications that we just want to support or sponsor hackathons, etc. Another big venue of the work that we do is education. So we try to participate and encourage the spinning or the growth of communities that are part of zero knowledge and learning zero knowledge or cryptography in general. So one of the efforts that we're doing is spending a summer camp for university students in 3 different countries. About 60 people, I think, is what we're targeting. There's also a bunch of learn and share sessions that we have done over the past months and years. Those are sessions in which we invite authors of papers to present like different topics. So for example, COC, or semi-COC, or NOVA, or other new proving schemes, or Hypernova. So we, Sangria, and I think Lookup, like there's been a bunch of like recent papers and innovations and advancements. And we try to invite them to these learn and shares, which are 100% open and recorded, to explain the paper, read it with us, and answer some questions. And yeah, there's a bunch of other types of education that we also do for builders. So education for researchers, education for builders and engineers, and education for just individuals like users about the importance of privacy or the importance of the need to scale Ethereum. Yeah, I think that's a bit about what we do. I would highly suggest that you visit us in our website to also learn a bit more about what we do. We actually had very recent revamp of our logo, identity, and website as well. And soon it will change the domain, but yeah, you can still access this. So as I was saying, we build programmable cryptography, and we want people to use this. We want this to be useful. We want it for people to participate, and I think it's an amazing opportunity to reach out to different communities like yours to find collaboration opportunities. So if you go next, you can see in the second tab our project library. Currently in the website, I think there are over 30 projects, but we have way more. Some of them like already completed. Some of them are like very active. And I'm just gonna mention a few that we can see here on the screen. But then again, there's a bunch of others that we also support through grants, or that we just haven't, they're very new, we haven't added them to our website. So we built things like CKEVM, the community edition. So this is part of an effort to make a proof of all the blocks and history of Ethereum in just a single proof. And actually, a lot of our advancements have supported other CKEVM teams in the ecosystem to learn and to see different ideas and tools. We collaborate closely with Scroll, Tycho, but we actually have shared ideas with many other teams like Polygon or others, CKC, etc. We have other things like Skitter, which is like a zero knowledge Twitter. We have things like Semaphore, which is one of the most mature protocols that have been around since 2020, which is a way to prove that you're part of a group and also to make anonymous signals like voting. So it's a very simple protocol, but it has been used in many, many different places. We have tools like RLN, which allows to control spam in environments where everyone is anonymous. We have tools to run trusted setups. We have tools to build groups and manage groups. We have also a research area doing domain-specific languages. So you see, we are all over the place, and these are all just some. We have tools as well to interact with wallets and how to implement like zero knowledge easily on wallets. So yeah, you see that we are all over the place to different projects. And the good thing is like all of these is, again, open source. We try to involve the community as much as we can. And yeah, we want people to use them, to give ideas back, to fork it, etc. So next. Cool. So now that I've given a brief introduction about PSE and its projects, you might be wondering, okay, where do I contribute? How can I get involved? And there are many different ways. So the first thing that I would just recommend is, like, as with everything, just come onto our Discord and say hi. I'm gonna add the link. It's in our website, but there's also in my last slide a link to our Discord. And the reason for this is that there's a bunch of other interesting people, not only part of PSE, but in general in the community, building cool stuff that you might be able to collaborate and share ideas. Then I will say, try to explore the apps that are on our website and try them out. Like many of them have demos that you can just run from the browser. All of them, you can clone them locally. You can try to run them locally. And yeah, if you find something that interests you, something that seems like a good building block for your project, use it. If you also want to improve that thing in itself or that building block, we always have tons of good first issues or just GitHub issues that are available to be taken. So we encourage people to just go to our GitHub projects or just, GitHub repos, find some issues. And if some of those issues are interesting for you, just tag people and say you can take it or just submit a PR. So as with everything, you can fork it, you can submit PRs back to the main repo. You can build dApps on top of it. So that's something that we're always interested. If you find a good building block, and you have an idea of an application that you want it to exist, just use it. And we appreciate that a lot. And lastly, also, if you want to get involved and contribute, also feel free to apply for grants. There are certain areas that we hope to publish soon, in which we are very interested to just keep supporting teams. But if you have ideas, what many people have done is they just share the idea on our Discord, or they just ask who can they talk to share a grant idea, and if it's a good one or we seem it's aligned to our goals, we will definitely try to fund it or support it. Also, maybe you say, oh, there are so many projects and it's a bit hard for me to find a good issue to work on. A good approach is to just use the filters that exist. So there's a website called useweb3.xyz/contribute, and they build this good filter to just filter all the issues that exist in our repository in PSE that have a label called good first issue or help wanted or something similar. So that's a good way to filter in many different repos to something that is valuable. Then another way in which you can filter easily is use the project boards. So in the screenshot, you can see which issues have been taken, which issues are not taken yet, and which ones are maybe of higher interest for some people. So yeah, I would encourage you also to just go into the project boards and find something that you find interesting. Next. For that, okay. Now, with this brief introduction, just explain PSE in 15 minutes. So I'm sure you might have questions. So feel free to write them down. I think, I don't see a comment or chat function here. So maybe we'll have to wait until the end. Okay, but let's talk about this question that I got asked. How do we balance privacy and transparency? Can they really coexist, or are they actually contradictions? And I think this is a concern or a question that is very valid, especially if you are very keen to work on zero knowledge. So first, I will talk a little bit about how I see this and likely how organizations sees it. The first an important thing to mention is actually, privacy is really important and valued and already recognized by many, many different countries, even by the United Nations. So there's this Universal Declaration of Human Rights, Article 12, that says that nobody shall be subjected to arbitrary interference with his privacy. So it's actually supported in the Human Rights Declaration. Many countries also incorporate privacy elements in their constitutions, and it's very important for making sure that there are no attacks to individuals, their family, their home, or their correspondence whenever, like an arbitrary, powerful individual or organization wants to, basically overseas and disrupt privacy for every individual. Next, please. So I think in general, privacy and transparency are both important, actually. So when people say, I don't know, that a blockchain is transparent, is that a feature or is that a bug? I think it's a feature. But when we think something is private, is that a feature or is that a bug? I think it's also a feature. So I think both privacy and transparency are important, but it just depends on the context and the goal. So if you go next, please. How I see privacy is that privacy is really important to restore the balance of power between individuals, users, corporations, organizations, countries. So a good ethos that I've heard recently, and I really like this phrase, is like, we want to have privacy for the weak, privacy for the individuals, privacy for us, but also we want to have transparency for the powerful. In a sense, we want to make sure like funds, or we want to make sure like there's transparency to how public goods and how public elements are being used. I think this is really important. So we try to avoid, like a bad use of everyone's resources. So I think it's really important, again, that we build systems and cultures in which we can respect the privacy of individuals, but we can also ask for transparency for our organizations, corporations, to make sure that we are all doing good. And I think that's the key point. Again, privacy and transparency are both features, but we just have to think about the context and also the goals that we have for the systems that we are building. Next, please. And I think that a very important thing to remember is that blockchain in general and Ethereum in particular won't scale if we don't have privacy. So imagine a payment system in which I send you, I don't know, I pay you for a drink, but then that person who receives my payment can see all my history about where I've been, where have I paid, what things have I bought, how much money do I have in my bank account? Would we feel safe with that? Would we be safe to think like all my financial statements are public to everyone in the world? Probably not, right? So it is important for us to build tools to add financial privacy, identity privacy, interaction privacy on blockchain, and in particularly on Ethereum. So adoption on Ethereum hinges a lot on scalability, like cheap prices, usability, like wallets and abstractions, but also privacy. And I think it's also been mentioned quite a bit by Vitalik and many other industry thought leaders. This is important. And I think our role as developers, as members of a community, and also building cryptography systems or zero knowledge systems, it's important to remind us like the important role we have in the ecosystem thrive. Next, please. Now, getting a bit more into the practicals is like, which approaches can we take for privacy and for transparency? One thing that is important to mention is like, what we value as private differs greatly by culture. So maybe certain cultures are a bit more open to their personal information, to their status, to relationship, to their real user, to their real names, whereas other cultures prefer a more sober approach into sharing less data, a bit more private conscious. And yeah, like I've been reading, for example, studies. It says like in Asia, for example, it's a lot more common to use pseudonymous. So like a username that doesn't relate at all with your real name. Whereas in like maybe Latin America, to give an example, it's a lot less common. Now, even with those subtleties, there are certain things that are important to be private for everyone in the world. And one good key to know which things are important, even when we build systems that are meant to be used by different cultures, by different people, is to give the option to disclose it when we want, to whom we want. So selective disclosure is an important topic and an important value to build into our systems. And what it basically means is that I, as a user, decide which information to show to whom, like to which party, for how long I want this information to be available to this person, and in which context. So for example, maybe I do want to show my financial statements, or just show that I'm solvent, or show that I have good credit reputation, or show that I've been to certain events, but without giving my name, my location, my other events. There are many things that we can build now with cryptographic systems. So we have our identity protected on the internet, but we also build enough trust and enough assurance so that systems like lending, like identity-based groups, etc., can be built upon. So again, I would say that in this privacy versus transparency debate, the important thing to remember is like privacy is very important, but we also want to collaborate and make sure that we can showcase or show information whenever we need it. So maybe if you go to the next slide, I also wanted to comment an interesting use case. So I don't know how familiar you have heard about Tornado Cash and the ban that recently happened last year by the US, and that kind of like affected a bit the censorship on Ethereum. But regardless of that thing, what happened? An interesting project emerged called Proof of Innocence. Yeah, I have like mixed feelings on this project, but what's interesting is that you can, as an individual, optionally and freely choose to disclose that one of your addresses, which is interacting with Tornado Cash, which is kind of like a mixer to get privacy in transactions, you can prove that one of your addresses does not belong to the addresses that were basically banned or censored by OPEC. So what you're proving here is that you're not a bad actor. You're proving that, at least for this entity, you're proving that you do not belong to the group that they are trying to censor and control. And this might be a way, an opt-in way, to build systems that are both privacy preserving for the majority, but transparent to people who try to break it, or people who are actually doing harm to the society, to the community, and yeah, to the ecosystem. Another one similar, and I don't have a slide for this, is the project RLN that I've mentioned in the first slides about our projects. It's a project that if you do spam, your private key gets leaked and you lose money and other people win money. So by doing mechanisms, designs like those, we can ensure that people have incentives to not misbehave, but actually have incentives to behave. And we can do that in a privacy preserved manner. So it's not an admin who knows everyone's usernames, but only if you behave badly, then you're punished by like specific action. But for everyone else, the interactions are private. So yeah, cool. So the fourth topic I was going to talk about is about the future of zero knowledge and machine learning from our PSE perspective. And as I've mentioned, like the PSE team is very big, so I think it's very hard to speak for everyone. And the other thing that I want to mention, a caveat, is that I'm actually not involved in many of the projects doing zero knowledge machine learning. But one of our experts or more knowledgeable members in our team, Dr. Kathy. So she is leading efforts on the CKML front. And I actually asked her like what were her views and her vision for CKML. And I'm bringing this to you today. Go to the next one. So basically, in zero knowledge machine learning, there are three scenarios. And the first scenario is, well, we have data or information and we have models. So the first scenario that we can analyze is what a scenario in which we have private data, but a public model. So what is this? Some applications that we can build this are, for example, biometric authentication or privacy-related interactions with systems. So let's say I want to prove that I belong to a specific country, but I don't want to leak my personal information, so that's private data. Maybe this country has a public machine learning model that I download or that I run locally, and I can prove that my identity, my passport, my ID belongs to a specific country, and I can make a proof that this computation was done correctly, but I'm not revealing who I am. I'm not revealing my identity. And there's a bunch of other cool things, again, like biometrics that we can do locally to make proofs. And in this case, I keep my privacy in my data, but the model is public. So everybody knows how the model was trained and what the weights of the model are. This, according to Kathy, is one of the furthest away from production. So it means that there's still a long way to go to see this in real life. What's basically is like client-side zero knowledge proofs in machine learning is still very expensive. It's basically not possible. Client-side are usually considered mobile or just your laptops, and those are not strong enough or powerful enough to run many of these zero knowledge proofs, which are huge on machine learning models. So yeah, basically we need to wait for better hardware or better proving systems. But yeah, likely this is the most promising use case for machine learning models as we are envisioning today. The other use case is public data and private models. So for example, this is I don't know how familiar you are with a system called Kaggle, which is a website which basically hosts competition on open data sets and open problems and ask people to submit their machine learning model. The cool thing of this is like thousands of people participate and they test according to a data that is common to everyone. And they basically, the best model with the highest accuracy or the highest prediction to some of the tests that are run on Kaggle is the model that wins, and they win a prize. Now, the problem with this is that everybody has to make their model public. So everybody has to submit on Kaggle their model. But what if we had all this public data on Kaggle and we had private models and we had ways to prove that our model achieves, I don't know, 99% of accuracy? What if we could, yeah, just submit and your model once you know that you are the winner? So this is a good way in which, and very, how to say this, already like a real world problem in which people might want to maintain their model private, but they want to prove with some public data that they can achieve a good level of accuracy. So yeah, right now you can only hide model weights, but not the architecture. So there are still some limitations, but there are people already trying and doing this. And in the future, we'll need something like functional commitments in which, quote unquote, we can hash the CKP circuit as well, which is like the model architecture. So this is also a bit far away, but not as far away as the first case. And the last scenario for CKML is when we have both public data and a public model. So this might seem counterintuitive, but this is, for example, machine learning rollup algorithm that proves that certain off-chain computation, which is available to everyone, is provable and it's correct. So yeah, you can verify an algorithm trading, a trading algorithm. You can verify and mint, for example, NFTs with a public machine learning model, with a prompt, for example. There's a bunch of cool things that we can do with this right now. So in this third scenario, it's actually achievable nowadays. It just needs to rely on very powerful servers. So it's still very heavy, computational heavy, but there are still reasonable models that can be achieved right now with this. So yeah, I think in this one, according to Kathy, there's still the opportunity to build applications with good UI and good UX to push the adoption and more research into this field. So these are the three scenarios that Kathy identified as long-term, mid-term, and short-term, and also some of their applications and future steps. One scenario that you might have seen that we're not mentioning is the private data and private model scenario. So like bottom right use case from this table on the presentation. And the reason for this is this actually not something interesting or relevant. If you have a private data and you have a private model, then when you make a proof to somebody else, it's meaningless to that person because they don't know what you are proving because the data is not there and the model is not there either. So it's actually counterintuitive, as Kathy was explaining to me, because yeah, maybe we think privacy, zero knowledge, like we want both a private model, private data, but actually that thing doesn't add much value, doesn't make more sense. Cool. If you click next. What are some exciting research focus or themes that ZKML people, at least on PSE, are looking at right now, but likely the group in general, is like recursion proofs via folding schemes. So things like Nova or recursive neural networks is something super exciting. And because it allows to recursively make a proof succinct into just one single proof and a huge computation, you can verify it at constant time. So that's very, very exciting. And yeah, you can see how new proven systems or folding schemes allows to unlock more novel and future use cases to be built upon. Okay, next. I wanted to recommend these resources if you guys are interested. Again, I think Kathy will be a great person, but there are also some repositories or communities to build. So there are good articles talking about just the research on ZKML topic, her work with PSE. And there's a good playlist, which I think explains very well. If this seems very high level and we didn't dive deep into ZKML, I think this video does that and also involves like how you can get involved. So, and if you're already familiar with this and already want to start playing with some tools and repositories, I do recommend ECKL from ZK100 and the Circum library for machine learning, which Kathy also like, and the team is starting to build. Okay. So if you hit next. So there was a fifth question that we asked me about like PSEs and Microsoft Nova like differences. Actually, I don't have an answer. I tried asking some of the team members working on this. So if you hit next, the only thing that I can tell you is that there's actually a good effort. Yeah, just hit next. Going on called Team Novi. And it's a joint effort between an organization called Zero Export or OExport and PSE team members to try to kind of like kickstart an ecosystem. So you know, Graph 16 and Circum is huge. We also have things like Plonk and Halo 2 and yeah, other like huge like zero knowledge ecosystems. They're trying to do the same thing with Nova, even though it's still very new. So there's a lot of like groundwork that needs to be done. And this is a cool site if you want to hear more. So I'm not as familiar and as involved with these teams, or with this effort, but I just wanted to share, like, again, there are different implementations, trying to compare this Nova with other elements, doing security analysis, doing building the verifiers, the on-chain verifiers. There's a bunch of work. Even like an application that we're trying to build to do recursive voting. Okay, just basically talking about Nova, but actually don't know the specific differences. But if you join to our Discord, you might get the chance to ask that question. So feel free to do so. And you hit next. And that's it. That comes to the end of the presentation. This is me on Twitter. This is the QR code if you want to visit us on our Discord, where me, myself, and all the team hang out, and also like a lot of interesting people around the world doing zero knowledge. And as I was saying, like we can always continue the conversation, and I hope we can see you around in more events, talks, and projects. So thank you very much. I don't know if we can open it for questions or
Yeah. Hey, Andy. It's a.
Hello.
Can you hear me?
Yes, I can hear you.
Hello. Yeah, great. It's a great presentation, and I think a lot of people get a lot of values from the presentation and get to know what PSE is doing and how to get more involved in the PSE. So one question is also collect some questions from community, and one question is how PSE initiate a new project. We know there's a long list of the projects in the PSE website, and also there's all ongoing like or for example the ZKML. And so from PSE perspective, how PSE discover new ideas and how to like, for example, make decision to perhaps set up a new project or maybe set up a new team to work around these ideas. So
that's a great question. I think because we cover many levels of the stack of the innovation flow that I call it, like people doing pure like research on proven systems, some people doing research on DSLs, some people doing on infrastructure, some people on applications. It's always like you get a bunch of different perspectives about which things are working well and which things could be better. So I guess like proposals from the team happen all the time. We do have like how to say this, like a lot of flexibility to add those into existing projects, like new ideas and proposed roadmaps. But if to start a new project and a new team, usually it comes from like proposing this to certain advisors that have been a long time with the team. So for example, Barry Whitehat is one of, I would say, like more known people on the CK space, at least on Ethereum. And he has a bunch of cool, crazy ideas that we try to build teams and execute on that. But also, like the rest of the team, share this with him, with OneSub, with other people who have been for a while on PSE. And basically, the best one of them get added and they get added. So those are ideas, let's say, that start from the team. But also, we hear tons of good ideas from the ecosystem, from external teams or just individual researchers or builders. And for those projects, I guess it's like very similar. Like they get pitched to some people. If they get some adoption and support, they get pitched to more other people. And once, the right people have like interest and approval, then we get some grant support from Ethereum Foundation or ESP team. So it's a bit how to say this, high level, and I don't think we have a super strict defined process, but it kind of like works like that. If that makes sense.
Excellent. I think another question is like when we were at Zalu, I also at the con, Vitalik mentioned that ZK will play a very important role in the whole Ethereum ecosystem. So from your perspective, how do you view this role? and how, for example, Ethereum, from Ethereum ecosystem or Ethereum infrastructure perspective, how to better to meet the corresponding the ZK future. Yeah, I think this is a lot of people are asking about the importance of ZK, yeah, in the Ethereum especially, yeah.
Yeah, that's a great question. So by many people, and I would also say Vitalik, like one of the main blockers of adoption for blockchain technology in general has been scalability, right? You want cheap transactions, you want a lot of transactions to happen. How do you achieve that without just relying on more powerful machines or, yeah, more powerful servers, which are basically meant to, how do you achieve that without destroying that decentralization? So zero knowledge is a clever way to do it. Like there are other technologies, you know, optimistic rollups and other, like before we have explored plasma and others, but like zero knowledge is a perfect technology because it allows you to prove that 100, 1,000 transactions were executed correctly. But then the rest of the network just needs to do a very simple computation, just verify. So that's the asymmetry of making a proof and then just verifying very cheaply that allows for a lot of scalability. So one is, yes, like the blockchain trilemma, scalability is very important. Zero knowledge helps a lot in that case. The other one is privacy. So we've said like Ethereum is a transparent blockchain as Bitcoin and as most blockchains, but we do want to give certain privacy elements so that my identity, my actions, my financial statements are not publicly available to everyone. So zero knowledge proofs allows us to do that. So for example, for ways in Tornado Cash, you basically made a proof that you owned a certain amount of money by proving that, yeah, just the leaf of a Merkle tree, it was on your control. So it's a clever construction that uses Merkle trees and zero knowledge to add privacy to the transactions or add privacy into unlinking certain wallets. So we'll see here, like we're solving privacy, we're solving scalability. And there's also another aspect which is less talked about, which is usability. So and actually, that's one of the things that maybe I was talking about at EdCon in Montenegro is there's an incredibly big world outside of Ethereum that uses cryptography, but it's not natively compatible to Ethereum. So for example, there are different signature schemes, there are different curves in elliptical cryptography that are used by biometrics, by payment systems, by cards, and we can all leverage all of those into Ethereum if we use zero knowledge proofs. So very expensive computation can be verified very cheaply on Ethereum. And that's the vision, that you can approve transactions with just your face without any need of complicated wallet or private key, that you can store approved transactions with your email because they are signed, your emails are signed cryptographically, that you can approve transactions with, I don't know, any system that uses public key cryptography, like public and private key, any system like that can eventually, that exists outside of blockchain, can eventually be brought upon Ethereum. And I think you also asked the question, like, how can we best prepare on Ethereum or on the ecosystem to leverage this? I think just like zero knowledge is a field that it's mainly driven right now by blockchain community, to be honest. Like a lot of the fundamental research is being funded and driven because this technology is basically like a perfect match for blockchain, which is like an immutable truth that is distributed everywhere. Like zero knowledge allows it to scale and be private where we want it to be. So yes, it's been consistently talked about zero knowledge as one of the key drivers of innovation for Ethereum and blockchain in general. And I continue to see this like proofs of storage, proof of nationality, proof of solvency, proof of education. Like anything that you interact right now, which requires some sorts of truth or source of trust, you can do it with zero knowledge proofs as well.
Yeah, that's great. Yeah, glad to learn all these impacts of the zero knowledge to the blockchain. And I have one last question from community members. Actually, it's quite technical, so it's regarding the implementation of CKEVM. So the question is, actually, I need to translate from Chinese to English. So it's that, so in the CKEVM, there's a lot of modules to basically, so the whole circuit is composed of multiple modules, such as state circuits, EVM circuits, and these modules communicate using lookup table, and where the lookup table is filled by the communication, the transaction trace dynamically. But there's a conflict that the Plonkish, the lookup table has to be pre-populated, which means that the corresponding content must be compressed in the verification key. So the question is how this dynamic trace in the lookup table can be implemented for the communication between different circuits. Yeah, I'm not sure this is you may be the right person, but there's some questions.
Yeah. Yeah, I think it's a fantastic question. I don't know the answer. There are several members. Yeah, I think our CKVM team is like 15 researchers, and yeah, several people work on different circuits around the system, and they're looking for ways to abstract all those modules interactions. So yeah, I think if you go to our Discord, you might be able to ask that and get a much better answer than what I can try to guess right now. But I think it's a great question.
So the best way probably is to put the question in the Discord channel, and that is probably the best way to ask.
Yeah.
Okay, great.
Okay, any questions from other people?
I think there's a question in the chat regarding the regarding CKML for what about I'm not sure I get the meaning of the questions. What about the private data from A and private model from B? Another question, is there a way to meet a PSE team in EthCC or EthGlobal? Yeah.
Yes, several members will be on EthCC. I think, no, actually on EthGlobal hackathons after EthCC. I won't be there, unfortunately, but yes, there's a bunch of like interesting people there if anybody of you is going. Yeah, I've heard about like federated learning and multi-party computation with like machine learning models, in which basically, yeah, you have private data locally on a private model, like private data A and private model B. Maybe that's what you're thinking about. And yeah, I've heard like some project ideas, but actually haven't got involved, and that's not one of the things that at least Kathy has identified as the interesting models. But actually, yeah, if I think about it and I understand correctly, I think that's still possible.
Cool. I think this is pretty much
yeah, almost in.
Yeah.
Huh? Go ahead.
Yeah, and we also run most of the time. So anyone, if you have further questions, feel free to post to the Discord, or you can share with me. Or specific questions to Andy, you can share with me and can forward the question to Andy. privately. Yeah, if you are too shy to ask the questions here. Okay, cool. So I think that's pretty much all we have today. And many thanks for attending today's share. So we will continue to have our ZK share next week. So welcome to join. And many thanks for Andy and give such a wonderful presentation of the PSE. Thank you very much.